today would be how many years in ladles? 50?
Yeah, 50 plus years. We manufacture anywhere between 300 and 500 ladles in a year. There are people who, do different kinds of linings and, to suit their application. But according to us,
What is the proper lifespan of a ladle?
People want maintenance-free ladles rather than people for maintaining the ladle. We must be the first in India to have indigenously.
I think if you buy a ladle from him, God will be with you. And all will be well.
Godwell will be with them, yes.
A couple of months ago, I visited one of the largest foundries in India, known to be the safest. And during my visit, a very large ladle filled with molten metal lost its center of balance and all the metal fell on the floor. Now, while the monetary loss was very significant, fortunately there was no loss of life reported. And that's why we are here today to talk about the proper maintenance schedules and the best safety practices for foundrymen to follow with their ladles in Coimbatore with Godwell Engineering products. Today would be how many years in ladles? 50? 50 odd?
Yeah, 50 plus years. I would say around.
When a company
52.
makes one product for 50 years,
exactly,
you can expect them to have mastery in a certain whatever you're making.
Yes.
And that's exactly why we're here.
That is why I said,
Right.
we are in this field for the past 55 years.
Correct.
And we design our ladles scientifically and based on our experience, meaning based on, hundreds and hundreds of customers' feedbacks and comments, right, and,
So,
pros and cons.
Coimbatore has some of the biggest foundries in India.
Yeah, yes.
So can you name any of your customers here? Because I'm sure they're going to be the best.
Yeah, we have, we supply to LMW, we supply to Texmo, Aquasub, we supply to Bratkin, we supply to most of the foundries in Coimbatore.
Okay.
We have more than 100 customers in Coimbatore and Coimbatore only. Yeah,
that's a lot of ladles.
Yes.
So how many ladles are you dispatching on a month, year basis? Like, what is the number like? I saw a lot of them ready.
Yeah, basically, we manufacture anywhere between 300 and 500 ladles in a year. And we have other products also where we supply ladle handlers and monorail trolleys and
right,
monorail pouring system frames also.
Right.
Yeah, that is our product range.
Amazing, amazing. And all shapes and sizes.
All shapes and sizes, yes.
So now, I think mainly we're going to do this interview in respect of safety, because I think that's your core value for Godwell right now today.
Yes.
So what does safety mean in terms of ladles anyway? Like, for a foundry person, when you talk about safe ladles, what does safe ladles mean?
A safe ladle meaning the operator should not be hurt, the equipment should not be hurt, environment should not be affected.
Okay, so like
three types of safety.
No harm to anyone.
No harm to anyone.
Okay.
And the environment.
What are some of the steps that you've taken to maybe foolproof the safety and build it into your engineered, as you mentioned, into your ladles?
The first and foremost thing is, the shell should not rotate by itself due to the shift in center of gravity. So we are using self-locking gearboxes. So wherever you stop the ladle at any point, it will be right there and it will not rotate by itself.
Right, because when we were filming, I was worried about whether the handle was going to actually swing and fall down on me. And then I realized, okay, there's some sort of mechanism that you're using that doesn't allow it to fall over.
Yes.
So this is like a geared motion or something? What
basically, if you look into a worm reduction gearbox, the worm shafts will be, smaller in diameter. But if you look at the, self-locking gearboxes, the diameter of the worm shaft should be higher. And there is a certain ratio, up to which the diameter has to be bigger, so that the self-locking comes into place.
Okay.
So basically, the worm shaft itself takes the entire load, and even though there is a shift in the center of gravity.
Right.
And the second point is, you should have safety guards in your ladles, which is equipment safety. So if your equipment is not safe, then it is going to, all these three safety parameters are interrelated.
Right.
If the operator gets, we should ensure that the operator is safe, and also we should ensure that the equipment is safe.
Right.
Because again, we cannot expect foundries to change their ladles every month or every 3 months or every year or so.
Correct.
And the third thing is, when you're using a ladle, you should follow the proper methods, and your ladle should be designed such that the environment doesn't get affected. Meaning, when you're tapping metal from a furnace, if the gap between the hook and the shell is too low, then it is highly difficult to tap metal into the ladle.
Okay.
So there is a design aspect, which may look very, subtle, but practically, that is very important.
So you would mean like you would be reducing spillage? Is that what?
Yes, you will have to reduce spillage, and you'll have to design the ladle such that there is no heat transfer, the minimum heat transfer loss. And of course, when we come to heat transfer loss, it again, there is another big topic coming, that is the lining.
Right.
Which we will talk later.
Yeah, and in fact, I think we should go with the lining next, because I think lining is something a lot of people spend a lot of money on,
yes,
a lot of time on, and a lot of people do it incorrectly. If they go for if they start using the ladle immediately without curing it and everything. So you're obviously how your equipment needs to be used.
Exactly.
So what would you think is the proper lining procedure for a ladle? Like, let's just go deep into that.
Yeah, actually, before going to the lining, I think I missed one basic point in the safety of a ladle. The structure should be rigid enough.
Okay.
Because you're exposing it to a higher temperature, and then you're cooling it down, exposing it to higher temperature. So there is a big variation in the temperature. So
right.
We will have to over design it.
So basically, you design in such a way that it's rigid. There's no
yes, it has to be robust. Let us say for handling 100 kg weight, let us say a shaft of diameter 25 is sufficient, but we use a 50 mm shaft. So which means the factor of safety, we are taking it about 2.5, because you are handling molten metal.
And also maybe because we are in India and people tend to overload their ladles. Is that?
We'll come to that point also later.
Have you seen
talk
those
about safety? Yeah, of course. Ladle capacity plays another big role.
Right.
So since practically I'm seeing a lot of people using the wrong capacity ladles, for pouring. That is another reason why we have to over design the gearboxes, because there is a vast shift in the center of gravity.
Right.
If we are using the incorrect capacity ladles.
Right.
So we have to take utmost care in ensuring that, okay, let us say it's a 1-ton ladle. People say at times we get very few quantities of 600 kg, where we have to pour only 600 kg. I cannot buy a 600 kg for this small lot of order.
Of course.
So they want to pour with the same 1-ton ladle. In which case, the metal will stay down. The center of gravity, the weight of the metal will be below the trunnion center, which
right.
means the forward tilting will be difficult. So in which case we'll have to, we design our gearboxes such that the range of the gearbox is, wider, where you can handle plus or minus 25-30%.
I'm sure all these practices would have come about as a result of learning. Like, I don't think this was all built in overnight. Like in the 70s, were you doing all this design?
Of course.
Has it come slowly? I mean, through learnings with clients and experiences, and maybe failures if in the past. Like
exactly.
How have you learned this technology?
So now that due to the increase in productivity, due to the quality of castings, the focus on quality of castings, and due to the because you want to avoid rejection, all economies of scale, and of course your reduction of labor and your highest possible production time, I mean value added time, and minimal or negligible non-value added time. So all these things have forced us to learn every day. In one foundry, one client will come up with a problem A, while another client will come up with a problem B. Both the problems will be contradicting. This person will say, no, this is not the problem here, this is the problem. No contradicting.
Correct,
so we will have to analyze, we sit and brainstorm with our team.
Correct.
And my dad is still, he's 84 and he's actively taking care of the production. So we all sit together.
I think that's also a really good point. Like when you're in business for 50 years making a single product, you've come across every single problem that could be under the sun. You heard this, you heard that, and all those learnings have been built and engineered into your products today. You know, so
Yes.
it's significantly gotten better over the years. So I would imagine there'll also be a scenario where customers come to you and say, okay, I bought a ladle from you 5 years back, 10 years back. Can you now modernize it and maybe, you know, sort of give it some retrofit where it's compliant today? Is that something that you
Yes,
also
we are
offer?
also doing that. We are also doing that.
Okay.
Life of the components is very, very important. Which decides and which determines the ladle life. Previously, people only available common metals were mild steel and gray iron. During that time, the maintenance were very high, and people were just welding the components to each other, wherever possible. And when my dad started, in early 1970s, one of our relatives who was manager in a big foundry in Coimbatore, he invited my dad and said, "See, this is the ladle I bought from North India. So for anything and everything, for any maintenance, I need a chisel and a hammer. And very often we have to change the parts. So this is taking a lot of time. Instead of using one ladle, I need to have two ladles as spare." So and then he had to think and then say, okay, you don't want to use the chisel and hammer. Target number one. Okay, let me not weld the parts. Let me bolt the parts together wherever possible. And then you don't want to change the spares. Okay, he's a core mechanical guy. So he had, he loved reading engineering books. So he went and read about, the different kinds of materials used in gears. Okay, he said, okay, why not phosphor bronze? I see phosphor bronze in all the books for a worm gear. Okay, let me start using it. So when compared to the gray iron or steel, the performance of the gearbox, the life of the parts, all these were, they increased significantly.
Right.
So these are all some of the things, why I meant to say this is, from the start till today, we are learning new things
Of course.
almost every day.
Right.
Yeah.
Right. So here you are 50 years later,
Yes.
and it would be completely, I mean, not taking advantage of the opportunity if I don't ask you what is the proper way to line ladles and also preheating, because that's also a big topic today. Like with maybe you said automation and availability of manpower and everything. So earlier it was a crucible era. I think Zircon must have been your biggest competition. Today is ladles everywhere.
Yes.
You know, so smaller foundries, of course, are still using crucibles, but I think the demand for ladles is definitely rising and definitely going to rise given our
Definitely,
production
yes.
thing. So how do you see, or maybe you could advise foundrymen as to some good practices as to lining as well as preheating your ladle?
There are people who do different kinds of linings, and to suit their applications, and of course they are also doing well. But according to us, if you're talking about lining, three main factors: the cost of the quality of the lining, the appropriate lining material, that is the composition of the lining material, and the proper lining technique. Because if you're going to use an improper lining material, then your metal is going to react with the lining. That is going to create quality issues. And if you are not using a quality lining material, then the service temperature of that material is going to be very low, where you'll end up with a high heat transfer loss, which means your production cost per kg of gray iron or SG iron increases.
You'll have short poles, you mean?
No, it will increase, right? I mean, if for example, let us say there is a heat transfer loss of about 50 degrees, between the tap and pour. So pouring, I believe, you will have to pour at a minimum of 10 degrees.
So they'll
for
keep having
gray
to send
iron.
it back.
So from tapping till pouring, if you want to pour the metal at 1420 degrees, you will have to tap at 1470 degrees.
Right.
So at the same, so your cost of heating that metal to 1470 degrees will be definitely higher,
of course,
than if you're using a proper lining material, which leads to a heat transfer loss of only 20 to 25 degrees.
Correct. So when you say proper lining material, what is the proper lining material? Like, what would you advise?
See, this is again, my opinion.
Yeah, I mean, of course.
Yeah.
Right.
Basically, I would want a material that will not react with the metal. So, which means negligible slag generation.
Okay.
I would want the lining to be of a higher
Anything
service
you can
temperature.
recommend? Like what sort of refractory are we talking about?
No, I'm talking about high alumina refractories. High alumina refractories.
Right.
And that is specifically of the non-wetting castable types.
Okay. Non-wetting high
non-wetting,
alumina.
yes,
Okay.
non-wetting high alumina castables. We recommend all our clients to go with that.
Right.
Because there has been a lot of scientific developments in lining materials.
Yeah.
We have seen, significant improvement in casting quality, significant reduction in rejection of castings, and very very economic. Economics were very good when they calculated in the long run.
Okay.
Of the lining material.
So high alumina,
non-wetting castables.
Non-wetting. All right. Now let us get into ladle preheating. I mean, I think that was a little bit something that we did not touch.
Yes.
So what is a proper preheating sort of process that you follow?
See, basically for different metals, different lining materials, you follow different preheating techniques. For different metals, you follow different preheating techniques. Basically, to go deep into it, I think I need a lot of
right. But
time
off
to
the surface,
explain it in examples.
How are people heating up their ladles today? Like, is it just a normal gas burner, LPG even today?
Yeah, again, there are a lot of foundries that just have a burner, a manual burner, and a guy just holds, he keeps it on a stand, and it just preheats the ladle. Correct. And there are very good preheaters that are available in the market.
Okay.
That are of the latest technology, and they talk about the most efficient preheating process with the least cost per for preheating.
Right.
Yeah.
Right. So now, if I wanted to increase the lifespan of my ladle,
yes,
right? You obviously given me preheating, good lining. How long can I actually extend it to? Like, what is the proper lifespan of a ladle in today's time? Maybe 1 ton, 3 ton, 5 ton, 10 ton.
I don't want to quantify the life of a ladle because it depends on various parameters. The usage.
Yeah, of course. It's
how well you maintain it,
maintenance,
and how carefully you use the ladle, and whether you're using the right capacity of ladle, whether you're using the right lining material for the metal,
right?
Whether you're preheating it properly. There are a lot of things. So visually, if you look at it, I would say train your operators to use the ladle safely, because if they are not using the ladle safely, they are going to get hurt.
Right.
So the second point is use the right capacity of ladle, and the third point is maintain your ladles properly. Maybe the next topic we will be going to maintenance.
But just if you had to give me a ballpark figure, what are we looking at? 3, 5, 7 years, 10?
No, I would say, I have seen ladles being used for more than 15 years. I have, without any physical damages. So I cannot, immediately boast that, my ladle has been used for 15 years. You know why they were using for 15 years?
The credit goes to the customer. Not to
Godwell. Because they are, maintaining it well.
Right.
The usage of the ladle is very less.
You should send me to one of your customers. Let me ask them how they manage their ladle. I don't think they write back with this sharing their crazy.
So basically, how well you maintain it,
right?
How safely you use the ladle,
right?
So that determines the lifetime or lifespan of a ladle.
Right.
I would say, our gearboxes practically, based on the history of our supply of spare parts.
Right.
The worm shafts and the worm gears, we maybe to 2-3% of the customers we supply these spare parts during the first 2 to 2.5 years of operation.
Okay, so that's when it starts to show a little bit of.
And then the bevel gears, maybe about 5 to 6 years of operation.
Got it.
So to quantify it, this is.
Right. I pressed you for a number and you finally gave me one. Sridhar, I hope you're enjoying this. All right. So before we go into maintenance, if someone has a ladle which is about say 3.5, 4 years old, when you talk about wear and tear, physical wear and tear, and maybe they are having like a preventive maintenance sort of routine, what are they looking for in terms of wear? Like how does wear show up and present itself on a ladle?
There are, of course, two types of maintenance where you go preventive or breakdown. If you want to, know when your ladle needs maintenance,
Exactly.
basically, I would say, there are, your ladle will show signs of, when it needs maintenance.
So what are those signs? Just maybe a couple of
Let
them.
us say first visual.
Okay.
Physical damages to the shell or physical damages to the bales or the hook or the trunnions.
Rusting? Am I looking for rusting?
No, I mean, let us say, by mistake, if the operator goes and hits the ladle,
Okay.
or by mistake, if there is a leakage in the lining, and if you're not using the right lining, the skin temperature of your shell is too high, where the chances of deformity over a lesser period of time is very high. So there are lots and lots of reasons for it. So I would say physically you will be able to see the damages, or for example, let us say your bolt nuts are not tight.
Okay.
You very frequently use the ladle, and you don't use it in a very rough way because of the vibration and many other
Okay.
factors. The bolts and nuts get loosened very easily.
So all the basically all the bolting needs to be checked.
All the boltings need to be
And
checked.
what would you say is the frequency that someone should check
Let
bolt?
me come next to that. So I would like to mention two more points regarding the maintenance of ladles. The how your ladle shows that you need maintenance. Let us say the worm shaft and the worm wheel, there is a ply between the two, and if the ply is more because of wear and tear, if you are going to suspend the ladle, using an EOT, you will see the shell shaking by itself. So, which means there is a relative movement between the worm shaft and the worm wheel, which means
Okay. Some play.
there is a wear and tear there.
Right.
And again, if you can I quantify it? No, because there are ladles that are used for multiple pouring
Yeah, of
or
course.
tap,
The time
and
span is irrelevant.
there are ladles where 1 ton metal they take it and 1 ton metal they pour it. So in the case of 1 ton metal tapping and pouring, if there is a small
Right.
shake of the shell, people generally don't worry too much about it. But if you're going to pour 10 moles, 15 moles in that ladle, you need to control the ladle really closely. Otherwise, there is going to be metal spillage. So in that case, you need to be very
Precise.
attentive and
Yeah,
precise, on your maintenance and replacement of worn out parts. So maintenance, I would divide the maintenance into daily, weekly, monthly, and quarterly.
Okay.
I would.
So if somebody is watching right now and
Yeah.
maybe they are part of the maintenance team for the ladles, because as soon as I started my first internship, I used to go to see how the ladle was being done, and they would open the gearbox and they would have this red oil, the grease,
Yeah.
all inside, which was completely filled, and then I would see the broken gears and everything, and they would fix the gearbox back. They would do the lining with I think it was CO2 sand they were using at that
Yeah.
time.
Yeah.
So all this was being done, and I was 20 in my early 20s taking notes. So if somebody is part of that crew doing that daily maintenance, right? What is it they are looking for? They come with a flashlight. Foundries are dark. Where's the first place they look at every day, which is like almost 80%, like the Pareto principle. 80% of your work is just done by this one check. What would that be?
See, I mean, before I giving the details, I would like to give a disclosure statement, because most of the foundries now they are very short of labor, especially maintenance, and maintenance people are really struggling, even though they want to maintain their ladles.
Right.
For example, before 5 years, we don't get a lot of ladles into our company for maintenance. Even if we want to go and check our ladles, they would say, "Sir, don't worry, we have a lot of people to maintain it, and we are good." But now it's exactly the reverse.
Opposite, yeah.
I get minimum. I always have 10 to 15 ladles in my factory,
Right.
consistently that come to my factory for maintenance.
Right. Right. Right.
So I would divide this into the basic stuff. Like I said, daily maintenance, check the tightness of bolts,
Right.
check for physical damage. Weekly maintenance, remove the bearing caps, check for the lubrication, and check for
On a weekly basis.
weekly basis.
Okay.
And then monthly basis, you again check this and top up the lubricants,
Right.
and you will have to check if your bearings are working. How do I know if my bearings are good or not? There are very easy things that you can know when the bearings are not when the bearings are worn out. That is, when you bought the ladle was very easy to rotate, and after a 3-4 months, due to some reason, let us say, a bearings usually, the minimum life of bearings is 5 years. I have seen bearings working in a ladle for more than 7-8 years. So I'm just giving an example. Let us say your there is a sudden inconsistent rotation tightness.
Correct.
Sir, if I rotate the 10 degrees of rotation, it's free, and then it gets stuck, and then I have to give it a pull, and then it rotates, and there is an inconsistency, which means your bearing is not good.
Okay. So I would think the next problem for a foundry would be that communication between the operator and the maintenance team. Like most often, maybe the operator does not convey to the maintenance team like, okay, there's an issue here. I'm having to maybe put a lot more pressure into it, or there's a little bit of play over here. I'm not getting the proper accuracy. So in your experience, like what have you seen foundries doing it? Like who spots the issue first?
No, in my whatever I have seen, especially in the recent years, the operators, they give their feedback on a daily basis, or whenever they find it difficult,
Right.
because they are standing in that heat for 8 hours or
And
12
safety is
hours.
of utmost
Yeah, and
paramount
then
importance.
now because foundries are following all these safety audits and all that, they have to put the PPE and with their helmets and all that.
Right.
What should I say? They work with high discomfort,
Correct.
with that heat.
That's a
and with-
perfect word to describe it.
yeah, exactly.
Right.
So they never fail to give a feedback when a ladle needs maintenance. So it is the maintenance team that has to take care. And maintenance team, there isn't a ladle maintenance team anymore in most of the foundries that I visited.
Don't you think that's a good business to get into? Like start sending engineers to do weekly maintenance, monthly maintenance, like just a checkup.
See, again, people are looking at the economies of scale. When the margins are all going down,
Right,
and
right.
people want maintenance free ladles rather than people for maintaining the ladles.
Yeah, that's true. I mean, that would obviously be the first thing.
Yeah.
But I can also picture a time where maybe like, Shankar was just ordering something on Blinkit and it comes 5 minutes later. You could also schedule a ladle inspection, like, okay, this ladle inspection on number 2020, and the guy comes there on his scooter and he has a ladle inspection behind. Do you think that's something that would take off?
See, actually, we are also finding it very difficult to get skilled
Technicals.
people.
Right.
So, there are limitations from both the supplier and the client sides.
Correct.
So we are trying to, improve, the quality, the
Correct.
design of our ladles, such that, the requirement of maintenance is very less, and the frequency is higher.
How is modern technology helping you design better ladles?
It helps us in designing safer ladles, high efficiency gearboxes, safety in the sense, we do ultrasound test on all our shafts.
Okay, ultrasound test.
UT, yeah, we certify, we give our customers UT certified parts, and the worm wheel, which is the heart of the gearbox, we do radiography, and then we certify radiographically. And we use CAD softwares
Correct.
to design and analyze the structural the strength of the materials we use.
Correct.
For example, we use SolidWorks for analysis of
Weak points,
the
you would say.
finite element
Right.
analysis, we say it.
Okay.
And
Right.
we also use ANSYS to do the finite element analysis, and we determine the factor of safety of the parts. And one more thing is, there are a lot of modern techniques that have come into place. For example, previously we used to fabricate certain components, but now we have a laser cut, and they bend the components, and they just give you an aesthetically pleasing a finished product, rather than you sitting and doing the welding, cutting and all that. And previously, we used to use conventional lathes and conventional machines, where the repeatability was comparatively lower. So the consistency of the spare parts that we supply, was not as good when compared to the CNC machines that we have, where the repeatability is excellent. And some of our suppliers, they do the inspection by themselves and give it to us. So the quality standards have
Has really
increased a
increased
lot
based on the equipment that you
based
now
on
and the
exactly
technology, adoption of new technology that you
adoption
have.
of new technology.
It's very nice to see that technology is being adopted not only in the foundries but also on equipment for foundries. So it's
Exactly,
also transitioning
exactly.
into foundries ultimately as a benefit.
Yes, yes.
Right.
So
That's great to hear.
basically, we are looking at building the best product at the lowest cost, with the highest possible performance that we can provide.
Right.
Yeah.
Amazing. So, what are some new innovations that Godwell is doing today for to keep your ladles up to speed?
Basically, we have started manufacturing ladles with the motorized tilting options. We have supplied, to the TVS Group, and now we are going to supply to Hindalco and Tata Steel.
So these would be very big ladles.
They are, yes, of 7-ton and 6-ton capacities. And we have already supplied these motorized ladles to L&T, and now they are out of business in Kansbahal.
Right.
So we have supplied a motorized, we have started manufacturing motorized tilting ladles.
So how does the motor work? Like it's a button?
Basically, we are keeping our main gearbox as it is, because the safety of the ladle is very important. We need a self-locking gearbox. So we connect the another gearbox, a geared motor, to the input shaft, using a clutch. So if people want to use it, people want to rotate it using the motor, the clutch is in auto position. And if there is some issue in the electrical side of the ladle, then it is just shift of the clutch to the manual mode, and they'll be able to rotate the handle manually. So this is
very
and we,
user friendly.
yeah, very user friendly, and we provide the geared motor is completely kept in an insulated safety cover. And we also provide sensor activated locks for the ladle. And we also provide according to customers requirements. So I would be very proud to say that we must be the first in India to have indigenously created designed this and supplied with all these factors,
Motorized.
all these features. Yes. And we
Amazing.
supply with a wireless remote pendant.
Okay.
Yeah, so people know the operator doesn't have to stand near the ladle. He can stand far away from the ladle, and he can operate the ladle.
Very cool. I'd like to see
Yeah.
some. If you do have some videos of these in action, do share. I can maybe circulate.
Yes, I have a video which I can share it to you.
Right.
Yes, yes.
That's very nice.
And we
So
have also started manufacturing motorized handlers for the monorail systems. Right now, still more than 70% of the foundries are using the manual handlers, which has a big wheel, and when they are pouring the ladle has to be brought from down to up because of the trajectory of the metal. They have to bring the ladle up and closer to the mold box or away from the mold box, depending on the trajectory of the metal flow. So for that, they are using ladles that are manually operated. Lot of foundries have tried moving to electrical hoists, but because of the ropes or chains in the electrical hoists, and they are very flexible,
right?
People find it very difficult to control the metal flow
There'll be a lot of spillage as well.
without
Right.
spillage.
Right.
So these ladle handlers are very rigid when compared to the ropes and chains in electric hoists. So one of the pioneers in handler technology, I would say he was the one who discovered this. He used to make it before, but now we have also started making motorized handlers, where again people can just with the press of a pendant, they'll be able to focus more on the metal flow rather than spending energy on rotating the handler as well.
Right.
And in places where there are some foundries that say, I want the longitude, the long travel and cross travel as well. So which led to our designing the bi-rail pouring system, where we have the LT and CT movements in addition to the up and down movement in the pouring system itself. Yeah.
Good stuff.
Sure.
I think next time I visit you, you probably have a lot more.
Of course, and now we are indigenously developing an automatic pouring system.
Okay.
Which I will give details after February, because that is still in the pilot stage.
Is it going to be ready for this next IFX?
To be very honest, unfortunately, we are not participating in IFX 2026 next year. So we are hoping to do that the year after next.
The year after that.
Yeah, because we wanted to,
be ready when you present it. Right.
New technology. So that will give us a very good leverage in entering into the market.
Right.
Yeah.
So today you are also exporting ladles.
Yes, we are exporting ladles to UAE, and we have exported to Indonesia. We have exported to Qatar, Saudi Arabia, Oman.
Are there a lot of foundries in the Middle East?
Yeah, there are significant number of foundries in the Middle East. Yes.
Okay.
Yes. The big challenge in supplying to the Middle East is we have to compete with the European quality. And by God's grace and with the policies of my dad and myself, now we are able to compete with the European standards. And we are supplying more than 5% of our annual revenue as exports.
Oh, okay, that's good.
Yes.
And how are these inquiries coming to you? Are you actively going out, or they are searching you out?
The truth is, all these foundries started maybe in the late 80s or 90s. And most of the foundrymen were taken from Coimbatore, mostly Tamil Nadu. When you talk about foundries, I think maybe Rajkot is the number one still.
Right. So it's not only hotels and hospitality sector that are stolen from the south. Tamil Nadu, it's also foundries.
Yeah, foundries. So since we are there,
so it's not uncommon for you to get a call from Qatar and the person is speaking Tamil.
Exactly. That is what actually happens. That is what actually happens. The Arabs will they will come into play only when all the technical specifications are frozen,
right?
And we are talking we start the commercial negotiations.
So India is not pouring for India; India is pouring for the world.
Of course, yes.
That's why I'd like to congratulate you on that.
Thank you.
Right. So I think we're pretty much covered with everything. Is there anything else that you'd like to add?
Yeah, basically, we over design. Once our customer, always our customer, 90% of our clients. And when you come to us, you are 100% sure that you are getting the best, most reliable, robust,
and safest,
and high performance product. Right. Of course, safety is our utmost factor when we design it. Yes.
Right. Yeah. So I think if you buy a ladle from him, God will be with you, and all will be well.
Godwell will be with them. Yes.
Yeah, I think I think we should end on that note.
Yes.
So thank you so much, Sridhar, for
My
doing this.
pleasure, Ian. Thank
Yeah,
you. Thanks a
really
lot for the
amazing time in
opportunity.
Coimbatore.
I mean, it's a very good opportunity for me to,
Right.
interact with a lot of
I
my
think you'd probably be the
prospective
only
clients.
ladle manufacturer on the world on YouTube.
I see.
Because
Okay.
there are people with have been interviewed for furnaces, for high pressure lines, for 3D printing, for
Okay.
core shooter machines, for CNC machines, of course, spectrometers, of course. But ladles, I think it's really amazing today that you're talking about a story on ladles, and you're actually going very deep into technology, and not only from a safety point of view, but also into like low cost automation, like you mentioned, with the auto robo pour, and now the auto pour that you're developing,
Yeah.
and all these technologies. So it'd be really interesting to be back and see how you've grown in the next 1-2 years. I'm
Definitely.
definitely
Yes.
coming here when the auto pour is ready.
Oh, yeah, sure. We will do another, we will definitely chat about it.
Right.
Yeah. All right.
Thank you, Sridhar.
Thanks a lot, Ian.
Thank you so much.
Yeah,
Thank you
thank you
guys
for
for
the
watching. Thank
opportunity,
you.
and thanks a lot for, the viewers. And I hope that, you got some points from whatever I've been, from my information. Yeah.
Thank you.
Thank you.
Thank you, guys. So now that you've understood just how important ladle safety is and the proper maintenance procedures to follow for your ladle, it's now time for you to buy one. And you can do so with Godwell Engineering products in Coimbatore. Thank you for watching, and we'll see you on the next video. Cheers.